Welcome to this Trimble Business Center video tutorial. In this video, we will work with the TBC tutorial data processing DJI aerial survey data. The main topic of this video is the ground control point measurement. I will use here the project from the previous video, Tbc Apm tutorial full course adjustment report. Therefore, here we have data where we already have run the baseline processing, and we want now to import our ground control points. You can also import them at the beginning together with your images, but as I want here to cover this topic in more depth, I will now start to import the data. When we look at the tutorial data, then you will find in the subfolder data the CSV file. And here we can see the ground control points. They are in the California state plane 83 coordinate system 0402 with the GeoEat 18 in feet. And this is important. We need to have the coordinate system of our project in this system. So that means when we check here in the coordinate system itself, this needs to cover the correct coordinate system, as the coordinates will be then of course here imported. And if your coordinate system does not include the GeoEat, if it's without the GeoEat defined, then of course this is then wrong, because our ground control points now here that we have, they are also using the GeoEat 18, and so then you will have a height shift between your GNSS and your ground control points, because the images, the drone images, they are imported, transferred into this coordinate system. And of course also the units need to fit. So in our case here, we have here US survey foot, and of course this also needs to be in US survey foot. When we take a look now at the coordinates itself, so when we open this in a notepad or something, then we now see here that our points are ID, and it's not east-north height, but it's northing, easting, and height, and therefore you need to choose here the correct column definition of our ground control points. We can do this either by drag and drop, so we can use here the drag and drop, and then typically the import editor opens up. In case you have a different extension that is not automatically detected as a ground control point file, you can also just go through home and select import. Then on the import page you navigate to your folder where your ground control points are, and you can select it here, and then I will go to my folder where the data is. Then we say OK, and then we can now see here this file, and now you can select it here, and there's here the import format editor also selectable. That means you can enforce that this editor will be used now to import our data, and now we can here choose what format our data is. So in our case it's here point ID, northing, eastern, elevation with control quality. Yeah, so this is then also now possible to be used. Then you can hit the test, then you see here the preview, and then we can now see that the first line we are not interested, so we can say next. We can use now here how these columns have been separated. Are they a fixed length, or is there some delimitator, which is the case? In my case here, we have here really the comma as delimitator, but if not, you can choose here something different. And then I can say here, I do not want to start from the line 1, but I want to start from 0. I want to start from line 1. CSV is correct, so this is fine. And I also want to import them, very important, as control points. Yeah, so this is very important that you here don't have here something different selected, because we want to use them as control points. And then when everything is here correctly set, you say next, and then it should show now here the correct setup, which is right, point ID, then northing is this value, easting is this value, elevation, import. I will not save it because I want to keep my default settings for CSVs in this part, but my control points are added to our project. In TBC, you will find them in the Project Explorer. So if you have not here the Project Explorer, you can activate it from here. And then when you go to the points, we have here our drones, and we also have here our ground control points. And what I will do is now, just for visualization here, I will select all my drones here as points. Then I right click it, and then I will here in the properties move them to a different layer. So I can just here go to the layer, select here to generate a new layer. I will call this image ID, and then on this image ID I will then here have my image IDs moved. And the advantage, I don't want to import it, I just want to create this one here. And then we can here close this part, and I will open now the view filter manager. And here, if I scroll down, you see the layers, and I can now switch them off. And now we can see our control points, which are only 3 control points. If you watched one of the previous videos about block configuration, this is not the perfect one. I would love here to have here in the 4 corners and one, but doesn't matter. We have GNSS, so we will measure the control point 502 now only, and then together with this measurement of 502 and with the GNSS, then to run afterwards again the adjustment with ground control points. So let's go back to the Project Explorer. I have still my images selected. I don't see them, but if I just left click here into the main plan view, then they are deselected. And I think let's select a couple once more. If I right click, I can also make, yes, here my clear selection. You can select the ground control points in different ways. You can here, of course, select it in the list. So if I click it here, you see it gets highlighted here. And then I can also right click here, go to the properties, and we can now see, if I expand here the ground control point and I go here to this entry, if I select here this icon, we can see this is now control quality, and the values that we have now here, they are now identical with this one here because we just imported them. So this value of 494506 is the same value like here, and of course also easting and northing of this point. Instead of selecting it from the list, I just clicked here to unselect. You can also click into your plan view, and when you click here, it will show you in this area all the possible selections, and then you can choose here 503 and then 503 selected, and the property window will automatically be updated. And of course also here, when I go into this part here, we can see here the quality. In this part here, this is where you can change it. Here only we can visually see it, but you cannot see here the status by clicking on this icon. So just always do not forget to expand the tree to access this if you want here to change it, or in this case also to see the quality itself by an entry. Later, when we will measure the ground control point, you can also type in the control point name. So that means we could then in the list later on see and just type in 502, and then this control point also will be listed or selected just by typing in the ID. So last thing before we start is showing also the prediction. So I go to photogrammetry, and then we will start now adjust photo stations with GCP. And as I mentioned here, we can go here to the absolute adjustment part. And here I can now I have first to click into this field, and now, as I mentioned, I could click here in this list to fill it. Well, let's do it here, this way here, or if we move this entry here, and we click here, and we select it here from the entry. So if I say here 502, or also, as mentioned, we can type it in, so 501, and then when you click the plus button, then we will now check all the predictions where this control point could be measured in. So that means, let's perhaps here just repeat a few little things. When we go to our import report, then we see in our import report that our average altitude is 262 feet. If we now project our images to this height, this is done by going to Project Settings, View, Referenced Image, and we enter here View Distance, and we exactly use these 262 feet. And we say OK. Then these footprints here are now extended, and it means now if we would now take a look at the photos that are now here represented. Let me see if I can select one. Yeah, here. So this photo here is in this case here. I would have to check which one is selected now here. But this photo here is the control point is inside this footprint, and therefore, or so if we use this one here, this control point is inside this footprint, and therefore it will be here listed. Yeah, so, or I have to go to 501. So 501 is here. So if I go here and select here a footprint, let's take this one here. So this footprint here is representing 501, and that means if I click now here on the plus button, then this image here I have selected should be now here in this list of predictions, and therefore we are now able to measure this control point here for our ground control point measurement. So for my plan view here, I will remove my viewing range here again back in this case here to a smaller size, just to have them visible only as representatives. So they will now here, this has no influence on our prediction. This is just a viewing distance, so independent in this case here from our measurement itself. So let's type in 501 one more time, click it, and then we still get the same list of photos. At the beginning, we see now here this white triangle, and this white triangle here is now the prediction where our ground control point is now displayed in our current orientation state and distortion model of our camera for this project. And you see it's not pitch perfect in the center of it. So therefore, because we did not use the ground control point itself for our adjustment. So everything is just based on our GNSS and the type points that we extracted. We also see that at the moment we have 0 observations for control point 501. So as soon as we would start to measure the ground control point, this will then change. Then this value will here be updated. And also we can change if this is here a valid ground control point, we can move it to, if we go here to the status, we can move it to a checkpoint. A checkpoint is like a floating point that will show us in the report later on the absolute error or the absolute quality, how this ground control point fits, or this checkpoint fits into our adjustment of this complete block. And disable is clear, it will not be used for our adjustment. It means here the status, as soon as we hit adjust, this will then be triggered and checked and then used for our adjustment. As soon as we click for the 0.501, the plus button, we are already in measurement mode. So of course the zoom level is important. So if you zoom further out, then of course your measurement will not be as accurate as if you zoom in. Still, what we use here additionally is also a magnitude, and the magnitude can be triggered in different ways. We have here, when you go to the options, there's an option here called photogrammetry, and here we can now change for this measurement mode the pixel picker. So the pixel picker is our measure function that we use, and there's a dynamic pixel picker. Then we can also show the pixel picker in grayscale, and we will also show how we can how we can toggle the pixel picker, the dynamic pixel picker, by a shortcut. This will then also be shown, and we also want to show the field of vision indicator in the plan view. So these are then our line of sight parts. Okay, so at the moment we don't have the dynamic pixel picker. Let's just keep this in mind, and then we say okay. It means if I now click here in my plan view or in my station view of this one photo here, then I will get here did I select here? Sorry, I have to I clicked too many times. Normally you click here and this is automatically highlighted and the pixel picker here is active. If not, you have to do this, and then I can click now here in, and then I get now here my magnification, and this is now where my real measurement is done. So the first one is just to define an area, and then I can now here make my measurement, and this is now this coordinate that I here define is now used later on in my adjustment. So I click it here, and now we see here there's now the status enabled. So this means this measurement is valid, and then it moves automatically to my next photo, because I have here automatically advance on pick. If I don't want it, then if you want manually always to click where you want to go next, then you switch this here off. And then just the same part, my pixel picker is active now. I didn't click anything in between. I click in this area, I get here now the magnitude, and then I can now here click to make my measurement. If you prefer to use a dynamic pixel picker, you can use Control and Shift. And when you do this, then your cursor becomes directly a magnification. And then you can here move it. You can also use, I currently move the mouse, but then you can also go here and then use the keyboard keys, the arrows, left, right, up and down, just to move it by a single pixel. And then you can here hit the Enter button to make this measurement that you have done. Again, Control and Shift moves again back to the other mode, and then again you are in the static one where you first click it, and then you can here make your measurement in the second click. In TBC, you can also have multiple views on different screens. So I can also here open the 3D view, and in the 3D view I can now here rotate this whole part with keeping the left mouse button pressed, and you see now here these orange lines. And let me first, perhaps I can right click here my tab and say here I want to show this here in a new vertical tab. So this view here is now on my right side, and here on the left side here I can still continue to do my measurements. And these arrays here, they can be changed the distance by going here into our project settings, going to reference image, and you see here this maximum length for the line of sight rays can be changed. And we know already this is now around 260 feet. I want to make it a little bit longer, so I will make it here 280, and just that they are here crossing each other at the bottom. And therefore we can also now see here these measurements where they are looking. We see the first 4 photos that I have measured. I can here just go back to this photo here. They are all coming from the first flying line, this first strip. And this is typically a 80% overlap. So therefore these 4 images here are from the first strip. And if I go now to my 5th one, then we will now see if I make my measurement here. First of all, I can see my line of sights. I see that here they are nicely here cutting through and the position looks fine. So that means in general, my orientation from these blocks is good. It's just that there is some shift between the GNSS and the control point. So I can now here make the measurement, click it here. And now we see here on the right side on my part coming here my new line of sight. And this is really also what we definitely want. We want to have measurements not only from 1 strip, but we want to have them at least from 2 strips. And it would be also good not to have just 1 from here and 4 from here, but perhaps here 2 or 3 and from here 2 and 3. And if they are even visible in this 3rd one, then also 2 or 3 measurements from here. Yeah, so if you do not want to measure all the images, then perhaps just measure every 2nd one here that is visible. This is already helping us a lot. So I will now skip here this one. I will just go directly to this one here. And then again make here a measurement. I zoom a little bit out because when I here click in, then I still will use the magnitude. And then I click this measurement and we will see now here comes now my 2nd measurement also from here. Then just to check, we see it also from the names, so 40, 41, 39. So let's check here out with these 80s here. And there's also one of the 80s here, very nice. And we see now the quality here, it's a little bit more blurred. So this is something then that we still want to have this measurement included. And when we look here, then no surprise, this is now coming here from the 3rd strip. And then here I will make here another measure from the 3rd strip. So really nicely connected here through the different strips. Of course, measuring all of them is not wrong. Ground control points are really our very important ingredient in this whole part. So therefore, please, I would do it. It costs me perhaps 2-3 more minutes. But if you want to spare it, then don't measure just the first 3. Then measure perhaps every 2nd, or look here at your strip names and just pick 2 measurements from each strip at least. This would give us a much better block configuration and therefore also a much better adjustment, the usage of this ground control point for our block. So I will now fast forward and measure the other 2 ground control points also, and then we will continue after this. Okay, here we go. I on purpose measured the control point 502 through all the images. There were sometimes trees here covering our control point. Sometimes image was blurred and I could not see the center of the control point. Sometimes also the angle was very bad, and so the texture on the control point panel was not easy to measure. So therefore, please always be aware, signalized control points help drastically to measure. I could also measure in the control point 502 a couple more measurements just by guessing where is the center of the squared panel. And this is really helping in many cases, in contrast to a natural control point, where it's sometimes difficult really to find it and to measure it. And then for control point 503, I use the approach to try to find 3 measurements or 2 measurements per strip, so that I still have a good distribution all over this part. What I will do now is I will move control point 501 to checkpoint, and just to use it here in our adjustment, not as a control point. And also control point 503, I will now here in my first run also move it here to checkpoint. So that means as my control point 502, which we can see here, has extremely many connections almost all over all the strips, which is a really nice placed control point here in our center, and we can see it here from all directions. We get here these measurements coming to this control point. This will benefit us now in our adjustment, and therefore it will help us also in the camera calibration. So when we hit the adjustment button again, because now we have a different constellation, I recommend you to take a look also at the video about block configuration, because now we have additionally to our GNSS, which has here a high precision, now also a ground control point with a high weight, and therefore we will again calibrate the focal length. And also what is now possible, because we have a control point, we can also apply a shift correction. We can shift the GNSS according, fitting if there's a systematic shift possible to apply it to this ground control point. And therefore then hopefully we will see that our checkpoints then also will fit much better into this adjustment, and we will then have here small residuals only in these checkpoints. If you have a measurement that you don't want to use, you can always use here the trash bin here at the end of each single measurement. And of course, as soon as you click on one of them, then I move to this photo, so 109, 109, and then we can see here where did I place my measurement. It's this yellow circle. This is my measurement. The white triangle is the prediction at the moment, and after the adjustment, this white triangle should hopefully then be reprojected better to our ground control point. And this is exactly what we want now to do. So we will hit the adjust button and then take a look finally on these results. So after applying the adjustment, we want to take now a look at our control point. So if we go to 502, which is our control point itself, then we see here that the white triangle and the yellow dot, they are almost identical, which is exactly what we expect from this control point and check and also the measurement itself. So here they are pinpointed to this point itself. Then in my case here, for example, at my checkpoints, I'm not happy with the results. We can still afterwards remove. We can say I want to move 501 into a control point and also 503 into a control point, just to use these ones also additionally for my adjustment. And then you can run again a post process. And this is again the advantage that you have when you have more control points in your block. You can here add control points. You can use them then for further processing, and therefore you can then run a second time an adjustment or a second time a post process. You have always to be aware, of course, how you define here these control points, of course how you measured the control points, and so they will then also be integrated into your adjustment process. So let's run it a second time, and then we will take also here a look at it. So here we go. We can apply again the adjustment now with all 3 control points considered for our process. And then after the adjustment is applied, we will take a look again on our results. So first let's take a look at our 3 control points. They should now of course fit perfectly because they are introduced as control points, which is exactly what we want. And if we go to 501, same thing happens here, mainly because we use them here also as control points. Then when we take a look at the report itself, then when we go into our block adjustment results, then we have here for the positions of our GNSS, centimeter accuracy. On the ground we reach 2 cm in position and 5 in height. And the GNSS is also with 4 and 3 centimeters here introduced. Then also we have here for our control points now a list. First, our control points are listed in the report file, and also now here we have them here listed with the accuracies, and they are fitting very nicely here, almost too good, because we added them with very strong standard deviations. So control points are always introduced in TBC. You can see it here in the block adjustment settings with extreme values. It's like they are godlike, millimeter accurate defined, and therefore they influence it very strongly. But the good thing is we see that the GNSS is here not breaking out. So with these 3 control points, the GNSS is still fitting very nicely, and therefore also our camera is newly defined. So when we take now here a look at our focal length, then we can compare this with our previous video where we only were running everything on the GNSS, and then we would see the difference here about it. Very important here is now this standard deviation value. This is now exactly what is mentioned in the block configuration video. So we have now a very good certainty about the focal length, and therefore the standard deviation here value is here very nicely to 1 micrometer. So I just took the video and stopped it here, and exactly what I mentioned. So you see the standard deviation before, purely based on GNSS, is here with 0.021, which is so 21 micrometer accurate, and therefore the focal length here is more biased just by the GNSS itself. And when we now compare this value here now with the GNSS and the ground control points, we can now see here that we are much better in our standard deviation and how we can predict here this focal length. And therefore also we see there is a difference. So there was now here a correction applied, and therefore this helps us now to make this fit nicely to our real ground control points. Okay, so we are ready with this data set to continue into our deliverables, which will be then shown in the next video. And as we already mentioned, it's not the best control point distribution here for this project, but we have always to be aware. We can see it here a little bit in the images, and also when I rescale it again, here is the road. So in this part where these 3 control points are measured, this is our main target area, and so therefore the GNSS still helps us to cover the whole project, but this is our main focus for this project here itself. Still, would be nice to have here perhaps, if this is the interest, to have perhaps instead of this one here, also here 1 control point, and having this one here more up here and the second one here, and then we could have introduced here a checkpoint, which then could also give us a correct full accuracy of this project with this settings. Okay. Thank you for watching this video again. I hope you enjoyed it, and see you in the next one. Goodbye.